My guest today is Professor Kent Berridge, who is Professor of Psychology and Neuroscience at the University of Michigan. His research includes addiction, psychology, emotion, and brain and behavior. Welcome, Kent. Welcome back, I should say, Kent.
I know it's great to be with you again.
Yeah, it's great. I mean, 4 years ago, at the height of COVID, we
Yes,
talked by audio.
purely microphone conversation. Yes.
Yes, yes. I have to say the video format is a lot better. So I have a few of your papers, and you've been doing research in this area for a long time. So we're going to go through some broad topics, but I want to start with something a little bit technical. Corticotropin releasing factor (CRF) systems promoting cocaine pursuit without distress via incentive motivation. You say corticotropin releasing factor (CRF) systems in limbic structures are posited to mediate stress-induced relapse. In addition, traditionally by generating distress states that spur drug consumption as attempts at hedonic self-medication.
Mm.
Yet evidence suggests that activating CRF expressing neurons in the central amygdala or nucleus accumbens, I don't know if I'm pronouncing that correctly, Kent, I know nothing about these things.
That's
So
okay. It's nucleus accumbens. Yeah.
can magnify incentive motivation in absence of distress, at least for sucrose reward. So from a naive perspective, what I'm understanding is that there's a system in the brain, CRF system, and it seems to kick in when you have some sort of distress. Is that how to understand?
Absolutely so.
Yeah.
It was a major discovery about 20 years ago that CRF, corticotropin releasing factor, seemed to be the brain's master stress signal that would trigger all
Hmm.
kinds of stress reactions, hormonal reactions, and other physiological reactions. Um, It's a neurotransmitter
Yeah.
concentrated in the hypothalamus and a couple of other brain structures like the amygdala, and there's some in the nucleus accumbens. And it's famously activated by all nasty things that are
Hmm.
stressors.
Hmm.
And so that's why it's thought of as the master stress signal. And the paper you mentioned on cocaine pursuit, it's really investigating the question of when stress happens,
Hmm.
is it that it's distressing, it's negative, it's painful, it's aversive, and so we consume foods or drugs or other rewards in order to make the badness go away, which is
Yeah.
certainly true much of the time, and that's the major hypothesis of viewing CRF, corticotropin releasing factor, in
Hmm.
addictions and in other motivations. But CRF also, in some structures, is triggered by nice events like getting a
Hmm.
unexpected reward.
Hmm.
And what we were asking was whether it was possible that CRF activation could intensify motivation
Yeah.
even in the absence of any negative distress or aversion. And the reason we're doing it is because in 12
Hmm.
steps programs for addiction, it's kind of well known that emotions of any kind, good, happy emotions, as well as negative distress, sad
Hmm.
emotions, can sometimes lead to relapse.
Yeah.
Emotions can be dangerous. And the question is, how can that happen? And one way that that might happen is that even happy emotions might trigger CRF activations in the brain,
Hmm.
and this might intensify the desire for things like cocaine. That's what we were trying to assess. And the answer
Hmm.
turned out to be yes, it seemed to do that even in the absence of distress.
So it seems very intuitive from a naive perspective. So um, clearly, controlling stress was very dominant for Homo sapiens from the African savannah. We could not have survived without controlling stress. There is an animal every corner we turned. It was a difficult life. So controlling stress would have been a very dominant system, I would imagine. And does the CRF fail in some way in some humans, or I'm going on a little bit of a tangent here, but I just want to get your perspective. Yeah.
No, I don't think it fails. I think you're right that it's very intuitive that,
Yeah.
nasty stresses have happened in our evolution and brain is disposed to try to find something to make the pain go away. And consuming rewards is one way to do that. So that absolutely happens. That intuitive traditional view of CRF as driving pursuit to reduce distress is very, very true. But it's not the whole story, and it's not the story for why happy emotions would trigger relapse. So what we were doing was really to try to turn on CRF neurons in the amygdala or in the nucleus accumbens using optogenetic laser techniques in rats to painlessly turn on their CRF neurons. And we knew it wasn't causing them distress because we would ask them separately. We'd ask them, would you like to turn on your CRF neurons? If you touch this object, you can have the laser come on and turn on your CRF neurons. And some of the rats would do that. So they weren't avoiding that as a nasty thing. They were, in some cases, seeking it a little bit on their own. But if we paired the CRF activation with the opportunity to get cocaine, what it did was powerfully intensify their desire to get the cocaine, much more powerfully than just wanting to turn on the CRF neurons themselves. What the CRF is doing is actually magnifying their desire for the cocaine in a way that dopamine in our hands has for many years. But now we're finding that even CRF, the nasty neurotransmitter, can act in a similar way in some situations.
Yeah, so we'll talk about this later, Ken. So what's fascinating for me, without knowing anything about it, is that there are a lot of specialization areas in the brain that is not purely specialized. You could got sorrow, you can have happiness, you can have anger, you can have distress, but it all seems to be processed in similar areas, right? I mean, it's a bit counterintuitive in some ways.
Yes, it is. And in a way, that's been a disappointment for neuroscientists because neuroscientists would love to be able to point to a brain structure and say that one is fear, like the amygdala, or that one is reward and desire, like the nucleus accumbens. And we've done that for many years, because to some extent evidence supports it. But it's very, very clear, as you say, that the amygdala participates in desire as well as in fear, and nucleus accumbens can participate in fear as well as desire. Some neuroscientists would say, well, maybe within these structures, there's still neurons, individual neurons that are labeled lines, one for distress and another for reward motivation. To some extent, that seems to be true, although there's other neurons that may flip their roles and generate different emotions in slightly different modes, the same neurons. So this is a puzzle, but it is part of what we pursue to try to understand what does what in the brain, what's dedicated to one emotion and what can flip and generate multiple emotions.
Yeah, so I don't know if this is new research, Ken. So I'm thinking, I have some engineering education. So I'm thinking there's some sort of hysteresis. So in some sense, if you sort of train your neurons in one way or the other, over time, that neuron specializes in one way or the other. So even if you have a very flexible structure to start with at time equal to 0, it all depends on what you've been trained on, right? In some ways.
Yes, absolutely. I mean, it depends on the situation of the moment, and it depends on our history of situations. One reason why it was thought for a long time why the amygdala, for example, is so famous for fear was because for decades, many studies studied it only in fear situations, in animal studies in fear situations. So it became very well known for that. But when you study it in reward-seeking situations and other emotions, you find it's participating in that too. Now, if we have an individual's history of either stressful, nasty situations or positive situations, then we're going to find the individual comes to a new neutral situation with this bias, the emotional bias, either to be afraid or to be appetitive in desire and seek it out. So all this complexity, this psychological complexity is operating in the brain at any moment.
Yes, so I mean, a lot of the experiments are in mice and rats, but we have 8 billion people, and maybe you have 2 billion kids. And from a policy perspective, your initial conditions matter a lot, it seems to me, from this, right? What do you think about that?
From a policy perspective, individual conditions matter a lot.
The initial conditions. So, suppose I take, kids from Africa or kids from India or Switzerland or Finland, the initial conditions are so different that it's really difficult to study them in some ways. I'm thinking,
Yes,
yeah,
I absolutely. I mean, that sort of draws upon the individual history, and these histories are going to be different in different cultures and
yeah,
different countries. So there could be personality differences that are sort of typical of national or regional groups.
yeah,
I think that's all true. But at the same time, we do have a kind of basic human flexibility and a basic human repertoire that can be called upon in
yeah,
different situations. And, so we bring together that shared heritage as
yeah.
well. Yeah.
Absolutely. So I want to go into somewhat a broader topic. I find this really fascinating, Ken. So is addiction a brain disease? So you say here, following are a few interesting issues for addiction. In what way is addiction compulsive, and in what way a choice? How do individuals differ in susceptibility to developing addiction? What are the crucial brain mechanisms underlying the transition to addiction? The essential mechanisms that cause addicts to be addicts? There are different ways of being addicted or different types of addict? Or does addiction always involve a common core mechanisms?
Well, I
Where
think there,
some, yeah,
sorry,
go
go
ahead.
ahead.
Yeah,
I
yeah, go
think
ahead.
there are tremendous individual differences in
Yeah,
vulnerability to addiction. Many people do take drugs that are potentially addictive, say alcohol or nicotine in the culture around the world, and yet many people can give it up or just use it recreationally and not become compulsively addicted. But some
yeah,
individuals do become compulsively addicted. So then the question is, what is special about them? What's the nature of the compulsion? And
mm,
in what sense is it or is it not compulsive?
mm,
Um, Even for very hard drugs like heroin or cocaine, the majority of people who take it in their late teens and early 20s, even if they're taking it intensely, the majority of those people will give it up by the time they're in their late 30s or mid 40s,
oh, wow,
you know,
okay. Yeah,
or at least reduce it down. So again, even for those hard drugs, most people don't become caught in a compulsion that lasts their lifetime, but
mm,
some individuals do. So again, the question is what's special? Now, I
mm,
think there are multiple ways of being addicted. And for many years, for decades, it was really thought that withdrawal, dependence and
yeah,
withdrawal was the
yeah.
essence of addiction. And for drugs like heroin or nicotine or alcohol, withdrawal can be very intense. And
So
these can be
because it's painful.
because it's painful,
Yeah,
absolutely. So again,
yeah,
it's going back to that logic that we take the drugs to make the bad feelings go away.
mm,
And this is still a major theory in neuroscience of addiction, the
mm,
opponent process theory, that says that's why we're doing it. And that is a powerful, powerful reason. People do take drugs to make
mm,
the withdrawal go away, and they take drugs to make other life situations, life stresses, socioeconomic stresses, personal stresses go away.
yeah,
All of that is true. So for people who take drugs for just that reason,
mm,
it's really a matter of relieving the distress. And if you can get them out of the distress, they might be able to give up the drugs. And for many people, that's true also.
mm,
Um, but for some people, it's also famous that some people become addicted and they go into detox programs,
yeah,
rehabilitation programs, and they give up the drug and they come out of withdrawal and they're not in withdrawal,
mm,
and yet they relapse. And this might happen even when they're not in difficult situations, even in
mm,
happy or supportive situations, they relapse. And the question is, it's really for them that we want to
yeah,
address the question, what's happening there? Incentive sensitization is a theory of addiction that was
yeah,
developed at Michigan by my colleague Terry Robinson and me
yeah,
together. And it was really based on two insights, or what we think, two truths about the brain that we think are true.
mm,
One is that dopamine systems in the brain that were for many years famous for pleasure, liking,
yeah,
actually turn out not to cause the pleasure of rewards after all, but they do cause the wanting for those pleasant
mm.
rewards. Um,
So, so,
that
so, so,
Go
so
ahead.
sorry to interrupt, Ken. So let's just define this. So you and your colleagues at Michigan, your hypothesis of almost 30 years now, I believe, has been that there's a distinct difference between wanting and liking. And I quite like this because I would imagine, again, from an evolutionary perspective, wanting would have given you higher evolutionary advantage, I would imagine. I mean, you have to get some food, whether you like it or not, it's not nature's problem. uh, but when you go in the other direction, liking, that's a slippery slope in some ways, right? Is that the way to think about it?
I think that's a very fair way of thinking about it, but your intuition is way ahead of where I was 30 years ago. Because 30 years ago I was one of the most fervent believers in the hypothesis that dopamine was pleasure liking. That was a hypothesis many neuroscientists believed it, but it was the chief leader of that was Roy Wise, who was then in Montreal. And he
Yeah.
had many experiments, animal experiments, really supporting the notion that if you suppress dopamine, the pleasures of foods, the pleasures of drugs, the pleasures of other rewards seem to drain out, and animals would gradually abandon those rewards as though they didn't like it anymore. They didn't want it, and
Hmm.
the thought was they didn't want it because they didn't like it. Um, my first experiments on dopamine were actually a collaboration with Roy Wise, and my only wish then was to add one more little piece of evidence to his enormous pile of evidence that dopamine was pleasure. But
Yeah.
we were looking at it in a little different way than he had. He had
Hmm.
been measuring animals working for these rewards or consuming these rewards, which they gradually abandoned when dopamine was suppressed. We were looking at it more the way human parents have asked their newborn human infants for thousands of years. Do
Yeah.
you, little infant, like the foods that we eat? By just giving a little taste of the food to
Yeah.
the infant and see what the baby does. Does it smack its lips and lick its lips and maybe want some more, or does it gape and not want any of that?
Hmm.
Um, it Primates like chimpanzees and even monkeys have similar facial expressions to sweet and bitter tastes as human infants do.
Even
Um,
mice, I think, right? Even mice, you said
well,
in one of
even
the, yeah,
even rats, mice to some extent,
right.
but rats even more so because
Rest.
rats are really
Yeah.
omnivores like us. They like sweet things. They like rich, fatty foods. They don't like bitter foods. Mice like sweet things too, but they're not quite as
Yeah. Not differentiating.
omnivorous. Yeah,
Yeah.
exactly.
Yeah.
And the rats don't have all the facial expressions, but they have some. So they can lick their lips to sweetness. They can gape and shake their heads and shake their paws and rub their chins to bitterness. Then
Hmm.
they'll do that.
Hmm.
We thought, and many things that change taste pleasure change these reactions. So when the rat is hungry, it responds with more positive liking reactions to sweetness.
Hmm.
Something like seawater, it responds to as though it's bitter. But if it had a sodium appetite deficiency, a sodium deficiency that gives it a
Hmm.
salt appetite, it responds to the seawater as though it's sugar. So
Oh, wow.
we
Okay.
thought if
Yeah.
we suppress the dopamine
Hmm.
neurons in the brain, that would reduce the liking reactions, like making the sugar less sweet.
Hmm.
And it didn't. It was a failure in my hands to do that. We tried it with several dopamine blocking drugs. Then we tried it with my colleague Terry Robinson with dopamine lesions that basically eliminated dopamine from the brain.
Hmm.
And the rats didn't want to eat anymore. They didn't want to drink anymore. We could keep them in good health the way we'd be kept in good health in the hospital through
Hmm.
artificial feedings and hydration. Um, but their sweetness reactions were absolutely normal, and they could still learn new likes and dislikes about things, but they didn't seem to want anything in the world. They were truly apathetic. That was the beginning of the thought
Hmm.
that, well, maybe dopamine is more about wanting things than
Yeah.
liking it. I didn't really
Yeah.
entirely believe it then. We suggested it as a possibility, but it really
So
wasn't.
when was that, Kent? What is the year?
That was 1989. That was the first
1989.
study.
Okay.
Yeah, so it's been 35 years. But in the next few years, we went on to turn on the dopamine system, and there we found that
Yeah.
again we turn on wanting but not liking. And at that point, I really started to believe the hypothesis.
Yeah. I mean, it's a fundamental shift, isn't it? I mean, it's counterintuitive for lay people. Wanting and liking are two different things. But for anthropologists, I think it may make some sense, which is wanting you have to get 2,000 calories or whatever the human body needs, and so I'm going to make you eat 2,000 calories. I mean, whether you like it or not is not my problem. Liking is a different thing. So it seems like the wanting thing is a much more elaborate process in the brain, almost like a survival mechanism, right?
Yes, I think so. The wanting systems in the brain are very robust. They're anatomically widespread. They're easy to turn on. They're difficult to disrupt entirely, so it's a survival mechanism that I agree evolved early. And in a sense, for early primitive creatures, it might have been all they needed, to respond to things that are food with wanting, to respond to a mate with wanting. And in a sense, as you say, liking is kind of added on. In a sense, it's a nice thing for us, a luxury. But why did it evolve? And there are suggestions, there are hypotheses for why pleasure liking evolved. People like Paul Rosen is a psychologist at the University of Pennsylvania, retired now. His suggestion several decades ago was that originally creatures might have evolved to want only particular things, like food and mates. But if you could have the capacity for pleasure liking, then you might stumble upon a new thing that you hadn't evolved to want, but turns out to be beneficial. And if you have the capacity for pleasure, then you can bring your wanting system, your cognitive systems to bear on this new thing and pursue it in the future. The liking is giving you this sort of signal. And that's probably as good a hypothesis as we have. It isn't a knockdown proof, and there are objections that could be raised, but it's about the best we can have.
It's almost like creativity in some way. So suppose I have a local optimization. So there's a global optimization problem. You get it 2,000 calories. I'm just making this up. Kent, I don't know anything about it. So body says, okay, so you have to get 2,000 calories. Go eat whatever you can get for 2,000 calories. There is a local optimization problem to say, well, I mean, if you like berries, you might want to eat some of those. And I like, if you like those, that's also good. So it's the liking part is sort of a local optimization problem. That's the way I'm thinking about it.
Yes, I think that's a great way of looking at it. It's a local optimization problem, but it expands the breadth of targets now in an adaptive way. To go back to addiction, though, shall we do that? So dopamine seemed to be more about wanting than liking. And my colleague Terry Robinson, separately here at Michigan 30 years ago, he was finding that addictive drugs like amphetamine or cocaine or morphine or heroin, for all individuals who take them, the individuals become tolerant. Tolerance develops, and we know about the neural mechanisms that are responsible for tolerance. Some neurotransmitter receptors actually go away, downregulation of dopamine receptors, for example. And then that deficit leads to withdrawal when the drug is stopped. And that happens in everyone. But those things go away if the drug is stopped and discontinued for a long time, for weeks and months. The tolerance goes away, the withdrawal goes away. What he was also finding, though, was that in some individuals, an opposite thing was happening in their brain, which was that their dopamine systems were becoming sensitized by the cocaine or amphetamine or heroin. And that meant that they were becoming extra responsive. So the first time they took the drug, dopamine was released. But if you gave them the drug 10 times, especially spaced apart, like taking drugs on weekend binges, but not taking it during the week, on the 10th time when he gave the drug, there was even more dopamine release than the first time. It had sensitized, and maybe twice as much dopamine release as the first time. This was sensitized. And once this happened, he found he could stop the drug for months or even a year and come back to the same rat, and they'd still be sensitized. If he gave it one more dose of the drug, it would be sensitized still. So the sensitization never went away. And
it's almost like, sorry to interrupt, Ken. So it's almost like the brain is running some sort of machine learning algorithm that says, I got a lot of pleasure with X. And then if I get 2X, I get a lot more pleasure. I mean, it's just like a regression equation I'm running in some ways. Is that the way to think about it?
I think that's fair to think about it to an extent, but with two caveats. The first is it's only happening in some brains, not in all. So this, even in heroin and amphetamine, it's happening in perhaps a third of the brains at street doses. You can sensitize all brains if you escalate the dose, but at street, traditional doses, only some individuals. But the second caveat is it's as though they were getting extra pleasure, but they're not getting extra pleasure. When the dopamine system gets sensitized, it turns out it's magnifying the wanting for the drug. But if we give them things that it's sensitized to and ask measurable liking, that doesn't increase. So the pleasure doesn't increase, but the wanting does. And so 30 years ago, created the addiction hypothesis by just saying if in some people who are taking drugs, their dopamine system is becoming sensitized, and if dopamine is mediating wanting but not the liking for drugs, then once they're sensitized, they'll have this very strong want to take the drugs. And even if they don't take the drugs for months or a year, they may still be subject to this intensified want. That's the essence of the incentive sensitization theory.
So let me ask you a loaded question again. So I grew up in South India, and it's one of those places where alcohol consumption per capita is one of the highest in the world. And so this is sort of going to the genetic question, which is, are the genes in the system that gives you extra pleasure to addiction? For instance, alcohol is I mean, they take well, I don't know. I mean, I don't live there anymore, but they take all sorts of drugs, but alcohol is sort of a prevalent drug. And per capita consumption, it's the highest in the world. So there has to be some genetic component to it, right?
I believe, yes, the answer is yes. And there's lots of evidence, both in humans and animals, that genes are very, very important in determining whether drugs are going to be used and then whether one's going to be susceptible to addiction. And there's many different kinds of genes and many different kinds of ways. So for alcohol, for example, people who have genes who can metabolize alcohol well and not become sick, they're more likely to go on to drink excessively, whereas people who can't metabolize it would be likely not to start on that route. Then among those who are using heavily, there's genes that are going to influence whether dopamine system sensitize or not. That's true in animals as well as in people. Genes are determining that. So many layers of gene effects determining whether we're going to use the drugs, and then if we do use them heavily, whether we're likely to become addicted.
So the metabolism part of this is quite important. So if we can actually sort of get rid of the alcohol, we're going a little bit on a tangent here, Ken, but I just want to get a perspective on it. So if you can get rid of your alcohol without any adverse effects, then you can drink more of it.
You can drink more of it. You can pay attention to the pleasurable effects. You can enjoy them, and you can escalate your doses. That would be the thing. But that kind of gene is very specific to alcohol, the metabolism of the alcohol.
Okay.
But things like the dopamine system are common to alcohol, food, cocaine. I mean, that's the common mechanism. And so when that sensitizes, then we're in a different domain. We're in a domain of potentially driving intensification of wants for a number of potential targets.
Yeah. So when you get sensitized, it's almost like a runaway train, isn't it? I mean, you take a little bit, you get sensitized, you take a little bit more. It's a curve that is continue to go up, right?
Well, it's a curve that continues to go up to an extent. I mean, there's a ceiling.
Some asymptote, yeah.
Right. And the question is, where is that ceiling? And that kind of gets to the question of is sensitized addiction actually compulsive, or is it not? Because there's a lot of controversy today, and has been for many years, about whether addiction should be thought of as compulsive or not. The people who would argue that it's not have good points to make. They would say that, first of all, addicts don't necessarily have to act upon their addiction. They can delay. You can, if in the face of rewards to not use or punishments to use, they may be able to avoid the punishments and take some rewards and not use for a while. They're not compelled to move their hand and take the drug in that sense. But I think there's such a thing as a motivational compulsion, which is a little bit more flexible. And we can all imagine a motivational compulsion. I mean, the mesolimbic dopamine system, it's involved in food and desire to eat too, right? And we all want to eat and we all enjoy eating. But if we were starved, if we were really starved, as people have been in concentration camps or in famines and things of that sort, then the thought of food becomes much more intense. The desire for food. People will eat shoe leather and chew on that. They will. There was a study done here in the United States during World War II. It was called the Minnesota Starvation Study. It was at the University of Minnesota. And it asked people, the government knew that people were starving around the world in concentration camps and such, and they wanted to know how to treat people to bring them back to health afterwards. And so they had volunteers who were conscientious objectors who did not want to go into the army and had a choice of going to prison or to participate in these studies. And they participated with eagerness, and they wanted, to do their part in this way. They were starved, voluntarily starved, down to very, 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 very thin. They looked like concentration camp prisoners. Okay. And they began to obsess about food, and they would get only small amounts, and they take a crumb back to the dormitory with them and kind of obsess over that. They would look at cookbooks as though it was pornography.
There's the pictures of food.
At the pictures of the food. Yeah. And some of them later in life, afterward they recovered, they developed eating disorders they had not had before. That kind of intensified wanting for food we could all have if we were put in that situation. But fortunately, most of us in our lives, we never have been. A sensitized addict may have the kind of desire for their particular addictive drug that a starved person could have for food. It's operating through the same mesolimbic dopamine system. You've elevated the ceiling that it can go to. It isn't that it keeps on going forever, but it's a very, very high level. And that's a kind of temptation intensity that most of us are never called upon to face in our life. And the question is, if we had that temptation intensity, could we resist, or would that legitimately be, in a sense, compulsive? Well, we could certainly resist once, twice, 10 times, but could we resist hundreds of times, if called upon to do that? That's what perhaps a sensitized addict is asked to do.
So I want to go to another paper, Ken. So separating desire from prediction of outcome value. So this has a lot of extraneous questions around, this artificial intelligence noise that we have. So individuals typically want what they expect to like, often based on memories of previous positive experiences. However, you say in some situations, desire can decouple completely from memories and from learned predictions of outcome value. So that's problematic for humans. So talk a little bit about this paper, yeah.
Yeah, I think it is problematic for humans, and in a sense, it's very counterintuitive to psychologists and our tradition of sort of being learning-based and cognition-based explanations for behavior. It's very non-intuitive to neuroscientists who adopt learning-based explanations for a lot of neural mechanisms for behavior. And it may be a little bit counterintuitive to computer scientists because, again, it's kind of going away from experience or even instruction.
Yeah.
But it's the stem of it, it all comes about from this flexibility of the mesolimbic system to be modulated by things like hunger or by things like sensitization, drug-induced sensitization.
Yeah.
You can reach into the brain and sort of turn on up the amplitude of desire. And some things are doing this in ways that kind of confound expectations. So in the paper that you read, I gave 2 examples from my laboratory, but I think there are examples in real life as well.
Yeah.
As such as an addiction. Should we talk about the people or should we talk about the animal experiment?
Yeah, so you have 2 examples here. As you say, 2 proof of principle examples are presented here to show how motivational wanting can soar above memory-based predictions of outcome value, wanting what is remembered to be disgusting and wanting what is predicted to hurt. And so this is a situation where 2 systems are sort of interacting in some ways, right? Wanting and liking things.
Yes, they're definitely interacting, and in a sense, they're changing together. But here's the thing.
Yeah.
In wanting what you know is disgusting, that was an experiment with rats who had learned that they could either get a lever would pop out and it would meant the sugar water was going to come into their mouth painlessly through oral cannula. And when that happened a few times, they would jump on that lever and nibble it whenever the metal lever came out because it was a sugar cue and they would love it.
Yeah.
They also had a different cue, a different lever that would pop out of the other side of the wall. And whenever it popped out, it meant that an infusion of not just seawater saltiness, but actually Dead Sea seawater saltiness from the Middle East Dead Sea, which is 3 times saltier than seawater, ocean water.
And they don't like
Very,
it.
they don't
They don't
like
like
it.
it?
If they
Yeah.
gape, it's disgusting. It's like swallowing a mouthful of ocean water, but 3 times that saltiness, right?
Yeah.
And they don't
Right.
like it at all. So they would avoid it when it came out. Then one day they woke up in a state of sodium depletion. They have salt appetite.
Oh,
And
yeah.
naturally in life, we could be that. Our ancestors were in that situation, and the deer and squirrels outside often are, because
Yeah.
they're not eating enough sodium chloride salts. But we've never been in that situation. Rats never in the lab never have either. But you can mimic the situation by giving them the hormones that are triggered in a state of sodium depletion.
Oh, wow.
So,
Okay. Yeah.
so they had those 2 hormones overnight, which turn on this salt appetite. And they woke up, and if they had the Dead Sea saltiness at that moment, they would have responded like it was sugar. Right? They would have. But what we wanted to do was, how would they treat the lever that was always associated with this memory of disgusting saltiness before
Right.
they had yet tasted the newly liked saltiness in its newly pleasurable state.
Right. Yeah.
So we first gave them the
That's
levers.
a beautiful experiment. Yeah. So what
Well,
happened?
it's a
Yeah.
classical psychological experiment. And what happened was, as soon as the salt lever popped out, they jumped on it and nibbled it as avidly as they ever
Huh.
nibbled the sugar
Yeah.
lever. They still liked the sugar lever, but now they suddenly wanted the salt, although they had never yet tasted salt as liked. Later in the day, they got the salt as liked, and that solved their sodium depletion. But that's the essence, that this incentive salience wanting system.
Yeah.
There's a name, a technical name for liking the salt more when they're in a sodium depletion state, or why we might like food more when we're hungry. The technical name is alliesthesia. It was
Okay.
coined by a French physiologist, Michel Cabanec. Alliesthesia, and it means change in the pleasure of the sensation. It's a hedonic alliesthesia that he was referring to. But the mesolimbic dopamine system also has this motivational incentive alliesthesia, which was turned on even before the hedonic alliesthesia ever was experienced in the rat's lifetime. It was sort of like a prescient mechanism that evolution had produced to make this work. So that's kind of saying, well, you can have this adaptive desire for what has been disgusting, and it's adaptive in this situation. Evolution allowed this to exist. The second example is a little less adaptive.
Yeah.
And it's a little bit closer to human addictions, I think. And this was another rat experiment, but what we were doing was pairing activation of neurons again in the amygdala, just like we did with the corticotropin releasing factor neurons. In this experiment, we were turning on all neurons in the amygdala. And we had known previously that if we turned on the neurons and paired it with cocaine, the rats would eagerly seek that cocaine much more. Or if we paired it with the sugar, they would eagerly seek sugar much more. If we paired it with just sugar and not cocaine, they'd seek the sugar and they'd ignore cocaine.
Yeah.
If we paired it with just cocaine and not the sugar, they'd become cocaine addicts and they would ignore sugar. So it was making them want whatever we paired with. Now, in this new situation, in this experiment, we paired it with something not so nice, which was an electrified shock rod. It's a rod that sticks out of the cage, and the rat does not have to touch it. It only sticks out a couple of inches, and the cage is big. So the rat can leave it alone. But rats are curious, so they will come over and they'll touch it once, maybe twice, and a normal rat would get a shock from this shock rod, and then it would stay as far away as possible, and it would bury the shock rod because there's sand in the chamber.
Yeah.
That's a normal defensive reaction to this shock rod. But the rats who had the amygdala stimulation paired with whenever they got close and touched the shock rod, they touched it, got a shock, and they would come back and touch it, and they would touch it again, and they would hover over it eagerly, and they touch it with their nose, they touch it with their paw, they touch it, they nibble on it and chew on it, and they would seek it out. It wasn't a defensive reaction. If we put a nice safety barrier between them and the shock rod, like a shoebox, they would climb over the shoebox 10 times, some of them in a single 20-minute trial, to get to the shock rod. It would pull them back. They do it again. They were seeking this out. So this is wanting what hurts. This is something
wanting what hurts. So this is irrefutable proof to your hypothesis.
Well, it's meant to be a proof of principle demonstration that it's possible that to want what is not liked and what has never been liked. That's the essence of it. And if we ask the questions, well, what's happening in their brain to make them want this? And we did ask that question. If we look at their brain right at the moment when they're being attracted to the shock rod, what we see is that it's not just the amygdala that's activated, it's the entire mesolimbic dopamine system. activation in the ventral tegmentum where the dopamine neurons start, activation in the nucleus accumbens where they project to, and several other targets. These are the systems that get turned on when we seek rewards like food or drugs or other rewards. And it's being turned on in these rats as they seek the shock rod that hurts them. They're wanting it in exactly the same neural and psychological sense that they would want a reward. And that's the essence, that we think is happening, say, in a person. If there is such a person, and we're told there are by psychiatrists who treat them, such a person who says, I've been addicted to this drug and I know it's ruining my life and I know I don't want to take it anymore because it would ruin my life. And to be honest, I'm not actually enjoying the drug that much anymore. And yet I relapse and I don't know why myself. Why am I doing that? I don't have an explanation. So when we first proposed the addiction theory, the only people who responded positively to it were a few psychiatrists who wrote to us and said their patients were saying this sort of thing.
Yeah.
So this wanting what hurts is meant to be a demonstration of a mechanism and the phenomenon that actually is this sort of thing where we want what we expect not to like.
Yeah.
But our wanting system has become independent of the pleasure expectation.
Yeah, it's so interesting, Ken. So, and I don't have any background in psychology or neuroscience, but this seems like wanting system is part of an operating system. So when you install Windows 11, wanting is in there. Liking is an app that you put on a little bit later than the hardware construction, and it's equally useful. But from an evolutionary survival perspective, you want. I mean, you had to be able to talk to your hard drive. If you can't talk to your hard drive from the CPU, you are dead. And so wanting is part of the operating system. Liking is an app. Is that the way to think about it?
I think that's a great characterization. That's a great description. I like that a lot. Yeah. So the wanting system, maybe it evolved originally even before liking, and now we're seeing with this wanting what hurts, you can turn it on independently of liking, and perhaps in some human addictions and compulsions, the similar thing happens. As you say, it's the operating system.
Yeah. So I want to finish up with your book. I think this is a book, The Incentive-Sensitization Theory of Addiction, 30 years on. You say here the incentive-sensitization theory, IST, of addiction was first published in 1993, proposing that a brain mesolimbic dopamine system mediate incentive motivation, wanting, for addictive drugs and other rewards, but not their hedonic impact, liking, when consumed. And B, some individuals are vulnerable to drug-induced long-lasting sensitization of mesolimbic systems, which selectively amplifies their wanting for drugs without increasing their liking of the same drug. So, yeah, so this has a lot of implications for policy also from an addiction perspective, right? So, can we do a genetic test to determine sort of a proclivity to addiction?
Well, there are behavioral geneticists who have done exactly that sort of thing, and they can find sort of gene signatures that seem to be predispose the vulnerability to addiction. I don't think we could do it on an individual basis and say this individual is going to become addicted, but there's a strong association conferring the risk. The 30-year on paper is a very recent paper with my colleague Terry Robinson, who's just recently retired and is now living mostly in Italy, but still intellectually active.
What?
And basically,
he left the U.S.? Come on.
Well,
he can leave the U.S.
He also maintains a home in Chicago, where his wife is a violinist in the Chicago Symphony Orchestra. So they live back and forth between those two places. But this was sort of a retrospective look. This was the same theory that we proposed in 1993, so over 30 years ago. And we thought, well, why don't we look back and see what the evidence in the meantime has shown? Is this theory still viable, or should it be thrown out? Because, I think when we proposed it in 1993, we thought it was a good idea for the time, but I expected that it would be replaced by something better that would come along, in the same way that the dopamine pleasure hypothesis, which I thought was a great idea at its earlier time, was, we thought, replaced by the dopamine wanting hypothesis. I thought something would come along to kind of change the way we were looking at the whole thing.
Yeah.
I'm sort of surprised 30 years later that the evidence has more or less supported the incentive sensitization theory, with even new human phenomena that support it. And so that's in the paper, the 30 years on paper, Terry and
Yeah.
I were kind of looking at that, looking at the objections that have come up over the years, looking at the critiques, and looking at the more recent evidence to see, did we still think it was true? And we do still think it's true.
So your 1993 paper, still one of the highest cited papers in this area. And so you guys were a little bit ahead of your time, perhaps.
Well,
And
it's
I
fair
get,
to say,
yeah,
I think
go
nobody
ahead.
believed us at the time. Very, very
Yes,
few people believed us at the time. It took
yeah.
10 to 20 years before people really started to believe, I think.
Yeah, I get a little nervous, Kent, when I see theories that stay on for a long time. I want theories to be broken. Um, Newton's laws haven't been broken. General theory of relativity hasn't been broken. Quantum mechanics, nobody understands, as they say, hasn't been broken. Um, Theories don't break in 100 years. I get very nervous about those theories. What do you think?
I absolutely agree. As I say, I expected this theory to be broken long before now. Some theories are more stable than other theories, and that doesn't mean that they're not breakable and that they won't be broken in the future. But something has to come along that gives us a new insight that's better, that would allow us to break and throw away the original theory. That can
Yeah.
still happen. It hasn't seemed to happen in the last 30 years, but it could happen in the future. Instead, what's
Yeah.
happened in the last 30 years is other new phenomena, like something that wouldn't have been expected, but is consistent with the incentive sensitization theory, which is the production in Parkinson's patients when new
Oh, yeah.
medications were invented about 15 years ago, the
Yeah.
production of behavioral addictions in people who had never, ever been addicted to anything in their life before by the new medications that stimulate dopamine receptors directly. That's kind of turning on wants, amplifying wants and narrowing it to particular targets in a very addictive way through dopamine stimulation. And there isn't a lot of pleasure involved in that, those behavioral compulsions. So those kinds of phenomena have helped persuade people that, well, maybe incentive sensitization has some stability and can apply to
Yeah.
even things beyond drug addiction.
Yeah. So Parkinson's is an interesting thing. So I think that's a profitable sort of area to pursue. Um, can we have some physical evidence that, we have some hypotheses, most of them seem to be true, but if you can apply this on some sort of physical system and we can measure outcomes on that physical system, then, we have a little better view on that, right? I mean, is that the way?
Yes, no, I think that's right.
Yeah.
And we have a bit of a physical insight into these compulsions in Parkinson's disease. I think when they were originally discovered, with the new medications being invented, in the middle of the 2000s and started to be prescribed about 15 years ago, 20 years ago, the original explanations were, well, maybe people were wanting to take more medication because they were in a withdrawal period between medication doses. So it was like a
Yeah.
withdrawal explanation. And maybe they would pursue other things also to kind of, again, get rid of the distress of being in withdrawal. Then it turned out that actually the desires, the intensified addictive desires, were actually strongest right after the person took the medication, when they had the highest doses on board. That was the first hint that it wasn't a withdrawal motivated phenomenon necessarily. It was really kind of medication motivated addiction. The best insight into the mechanism comes from a study, a PET study, positron emission study, neuroimaging study, that was published in England about 10 years ago, where they took Parkinson's patients, some of whom had these behavioral addictions of compulsive gambling or compulsive pornography pursuit or compulsive shopping, and others who were taking the same medications, but they didn't develop these behavioral addictions. Again, it's only some individuals who really seem vulnerable to the addictions. So there are two groups taking the same medications. One has the addictions. Then they took both of those groups, popped them into the PET scanner, and gave them one dose of L-Dopa, which causes dopamine release. It's like taking amphetamine, causes dopamine release. And what they saw was dopamine release in both groups. But in one group, the dopamine release was much higher to the same L-DOPA dose. And it was the group that had the behavioral addictions. This is exactly what my colleague Terry Robinson saw in rats 30 years ago when he was doing the first sensitized studies and found that sensitization increased the dopamine release to the same dose of drug. That's what we're seeing in these patients who have the addictions. They are sensitized. And the authors of that PET study said it seems to be that it's dopamine sensitization that's driving the behavioral compulsions, these behavioral addictions. Vulnerability to developing the sensitization, that seems to be the
vulnerability, to develop sense. So I don't know if this is in your research, Ken, but is addiction also a positive survival behavior?
Well, wanting is a positive survival behavior.
Wanting is clearly,
absolutely. And addiction is sort of taking that mechanism and sort of amplifying it and narrowly focusing it on a target in a way that is no longer addictive. It's more like the wanting what hurts phenomenon. I mean, no longer advantageous, adaptive, more like the wanting what hurts.
So what do we know of the 8 billion people that we have? What do we know, very roughly, what percentage of them are more prone to addiction to anything? I mean,
well, I think the numbers on addiction, it varies with the particular drug and how the drug is taken, orally versus intravenously versus smoked. And the numbers range anywhere from, say, 6% up to 30% for, say, intravenous heroin or cocaine, maybe 30%, but for other drugs as low as 6%. And in between for other drugs in the middle. So it's always a minority, I think, who are vulnerable to this compulsion, but can be a sizable minority. And when we're talking about millions of people, as you say, even 6% is a large group to deal with.
And we have different drugs now. We have video games, we have politics, we have social media. These are all sort of drugs as well. So what do you think about those?
Well, I think if you had asked me 15 years ago, I would have said I don't think the behavioral addictions like video games or gambling are going to involve the same sensitization mechanisms. And the reason I would have said that 15 years ago is because we knew something about how drugs, through molecular and cellular mechanisms in the brain, actually do sensitize the mesolimbic dopamine system. We know something about those mechanisms. And I would have thought, without the drugs, how are we going to produce those molecular and cellular changes? I should have remembered 15 years ago that my colleague Terry Robinson 30 years ago had shown he could sensitize the dopamine systems of rats without drugs by particular strong stressful experiences. But what's changed my mind in the last 15 years is not rat experiments, but it's rather the human neuroimaging studies of people with behavioral addictions that are showing some people, who probably the people who have the strongest behavioral addictions of compulsive gambling, compulsive binge eating, compulsive sex or pornography pursuit, they're showing brain signatures to cues for their addictions, like the site of gambling cues or the site of drug cues, the site of food cues.
Like the rat hitting on the thing.
Sort of lighting up of the brain, a hyper lighting up of the brain, an excessive lighting up of the brain's limbic wanting system, the amygdala, the nucleus accumbens, when they're looking at those cues, much more than the same person would light up to other non-addictive cues that they're not addicted to. And also much more than, say, a compulsive gambler lighting up much more to gambling cues than a recreational gambler who enjoys gambling would light up to those same cues, but the recreational gambler can take it or leave it, can walk away. This is the same kind of signature that people who are addicted to drugs often show to drug cues, lighting up in this really hyper intense way to their addictive drug cues. So the fact that they're lighting up in that way, in a sensitized like way, makes me believe that yes, for at least some individuals, these intense individuals, it is literally an addiction in an incentive sensitization sense. What we don't know is what's the percentage of people who are, say, having gambling problems. What's the percentage of them who are actually lighting up in this really intense way or not, and having other explanations. We don't know the demographics.
So I had to finish up with this, Ken. So if you look at longitudinally, as a percentage of population, people prone to addiction divided by the total population, is that number increasing over time?
I'm not an expert on that, but I would think probably, I don't think that the number of people becoming addicted is changing much over time. I think, the demographics of drug use certainly does change over time. So that can lead to a greater proportion of the population being exposed to the drugs. But I think the percentage of people who are exposed who then become addicted, my guess is that that's not changing so much over time. It does change as you change the drug or the route of administration, but those are the
that's comforting. I mean, otherwise we have a systemic problem.
Yes.
So
But we do have a systemic problem. I mean, the problem with,
Yeah.
say, opioid overdoses is that the new synthetic opioids are just so incredibly potent, much more times, hundreds of times or 1,000 times more than heroin. And so that leads to overdoses with tiny, tiny specks of drug. But that's separate from the addiction problem.
Yeah. Excellent. Yeah. Thanks so much for spending time with me again, Kent. Really enjoyed it. Thank you.
Well, I enjoyed it too. We'll have to do this every 4 years.
Every 4 years we'll do it.
Okay. Thanks a lot. Till
Thank
next
you.
time.